Hello, good morning once again. This morning we shall continue with the circle theorem. As I said earlier, we need to know the various parts of the circle so as to make things easier. When we say a circle is just a plane figure or object. When we say a plane figure, we mean something that we can only draw, a two-dimensional object, meaning something that we can only draw. And when we say a plane simply means a flat surface. A plane simply means a flat surface. So example of plane figures we have, which is circle, we have triangle, we have rectangle, we have polygons. When plane figures are put together, that is where it gives us what? A 3D object or solid objects. All plane objects do not have heights, as this also applies to a circle. Let's see the various parts of the circle. A circle has a circumference. When you say the circumference of the circle, we mean the circular parts. You see the circular parts. That's also called the circumference. The boundary of the circle, the edges, is called what? The circumference. The circumference. A line that touches two ends or joins 2 points on the circumference is called a chord. And this shall be used mostly in circuit theorem. In circuit theorem, all angles will be formed by chords. All angles will be formed by chords. All angles will be formed by chords. So we can see that we have chord what? ACD, chord CD, chord CD. We also have chord what? BA, chord BA, since they join what? 2 points on the circumference. Arc. When we say arc simply means a part of the circumference. So from here to here, this curved part is called an arc. From here to here, this curved part is called an arc. So this circle is made up of the arc what? A to D, D to F, F to E, E to C, C to B, and B to A. They are the various arcs on this circle. When we say a radius is a distance from the center to any part on the circumference. The distance from the center to any part of the circumference. So distance from here to here, the distance from here to here, the distance from here to here, from here to here, from here to here are all known as what? Radius. And they are always the same. They are always the same. That's why you check from here. We have O to C, O to C. You also have what? O to D, O to D, O to D. Let me do the correction. O to D. All being radius, and they are all what? Equal. We come to what is known as tangent. When we say tangent, a tangent is simply a line. As the name implies, tangent, it touches only a circle at a point. It's just a line that touches a circle at a point without cutting it. Without cutting it. It's a line segment. It's a line segment, meaning it ends. It does not extend. When we say a secant line, that is line from the diagram EF. A secant line is a line that cuts through a circle. It cuts through. A secant line cuts through and extends indefinitely. I hope we are clear. So moving forward, we see that there shall be involve only two figures in circuit theorem. We shall have the triangle, which is a three-sided figure. We have a quadrilateral, which is more than three-sided figure, meaning from 4 and above. Let's talk about their properties so as to make it simple for us to understand. Properties of triangle. All the sum in the triangle, all the sum of the angles in the triangle sum up to 180 degrees. All the sum of angles in the triangle, meaning interior angles of a triangle sum up to 180 degrees. And under triangles, we can group triangles into two based on, or describe them in two based on one, their size, and two, by their angles. By their size, we have three types of triangle. By their size, we have three types of triangle. One, a triangle that has none of the size equal. None of the size equal is known as what? Which is describing triangle based on size. One, we have the scaling, none of the size is equal, meaning not to scale. It is not drawn to scale. Isosceles, meaning only one of the sides is isolated, meaning the two sides are equal. And equal parts are indicated by lines. So two sides, this part and this part, is equal to that. Equilateral, all the sides are equal. So you see, we have used these lines to indicate that these three parts are all equal. All these three parts are equal. We come to a quadrilateral. Let's complete with the triangle. This one is description based on size. Let's go to description based on angles. There too we have three. So when we put all of them together, it means that we can say we have 6 types of triangles. By angles, when you say acute angle is an angle that's less than 90, and that gives us acute triangle. When you say right angle is an angle that's equal to 90, and that gives us what? Right angle triangle, meaning one of the sides of the angle should be what? 90 degrees. When you say obtuse angle is an angle that is more than 90, and that will give us what? Obtuse triangle, meaning one of the angles should be more than what? 90 degrees. For the other shape, which is for the quadrilateral, it must have more than 3 sides, meaning 4 sides and above. And this is how we do the properties. All the angles inside it must sum up to 360 degrees. An example of such, we have a square, we have a rectangle, we have a polygon, we have trapezoids. And this one ends the part 1 of the circuit theorem. The part 1 of the circuit theorem. You let me add this one before we end the part 1. Just go through them as I show you. I shall then bring the diagrams to show the actual parts as we work through. Angles are formed by chords. In circuit theorem, angles are formed by chords. Angles are formed either in the circle or out of the circle. Angles are formed in the circle by chords either at the center or at the circumference. Equal chords form equal angles at the same segment. When you say a segment, it simply means part of a circle that is bounded by an arc. That's bounded by an arc. Here is a segment. This part is a segment. If you want a sector, we can draw it like this. This part becomes a sector. A sector is bounded by, let's finish with the segment. It's bounded by an arc. This is the arc, and a chord. That makes it a sector. That makes it a segment. Segment is part of a circle that's bounded by an arc and a chord. When we talk about a sector, see the spelling sector. It has an R in it. So let the R remind you of the radius factor in it. The R remind you of the radius factor. So a sector is part of a circle that is bounded by 2 radii and an arc. 2 radii or 2 radius. The radius. One radius is this, and that radius is that. So this part becomes what? A sector. Sector. R. Let the R remind you that is made up of what? 2 radius bounding it and what? An arc. And an arc. So we shall end it over here. We shall continue with part 2, whereby we shall do the calculations involved and solve past questions. Thank you for your time.